This study is about evaluating prior concepts of the learner through problem posing approach and then go for discovering Johnson's algorithm exploiting the same approach. The research methodology adopted is of Govin C, which was proposed by Dr. D.G. Govin in 1980. Starting from theory, the series of concepts required for discovering Johnson's algorithm are minimum spanning tree, shortest path spanning tree, Dijkstra algorithm, Bellman-Ford, negative weight cycle, relativity, and reweighting. Moving towards principles, the students should be able to differentiate between minimum spanning tree and shortest path spanning tree. They should be able to realize the problems with Dijkstra if the graph contains negative edge weights, and they should be able to realize the shortest path properties and regularity. The constructs and concepts required for discovering Johnson's algorithm are again the same, including MST, SPST, Dijkstra, Bellman-Ford, negative weight cycle, relativity, and reweighting. This concept map shows the two single source shortest path algorithm that includes Dijkstra and Bellman-Ford. Dijkstra is a greedy algorithm that makes use of graph modification, and it may give wrong result in case of negative weights. Moving towards Bellman-Ford, it finds the shortest path from the start vertex, including the intermediate vertex, to the terminating vertices. It finds a 2-edge path which may update the shortest path of the terminating vertices. Johnson's algorithm make use of Bellman-Ford to detect negative weight cycle, and then if the graph does not contain negative weight cycle, it finds the shortest path, which would be definitely single source, and those single source shortest paths would be used for reweighting the graph, which would not disturb the relativity of the shortest path. This reweighting would lead to a graph that would be connected, weighted, but without negative weight. And if we run Dijkstra p times on this graph, we would end up with finding all pair shortest paths in much reduced time complexity as compared to fluid Warshall. The shortest path classification prior to Johnson include Dijkstra, Bellman-Ford, slow all pair, faster all pair, and fluid Warshall. And finally, after learning Johnson's algorithm, it is subsumed in the shortest path existing classification as shown here.
To evaluate whether a problem posing technique can be a good way to discover Johnson's algorithm, we conduct a study that was comprising, the experiment was comprising of 20 students that were chosen from advanced algos class and some senior students. The experiment was in the form of a quiz. The quiz was comprising of total 9 questions. The quiz was comprising of total 9 questions. I will show you the quiz. There was a help sheet for the first 6 questions. The first 6 questions actually were designed to check the prior concepts of the students if they were meaningfully learned. You can see the first question was showing the calculations of a spanning tree through a DFS technique. The second question is calculating the minimum spanning tree. The third question is calculating the shortest path spanning tree. And the fourth question is using a directed graph, and the shortest paths are calculated through Dijkstra's algorithm. The fifth question, the graph is having negative weights, and again Dijkstra's algorithm is used to calculate the shortest path, but the results are incorrect. In the sixth question, Bellman-Ford algorithm was used that finds 1 edge, 2 edge, and I edge paths till v minus 1 edge path, and the final result is the correct result. Still, even though the graph is having negative weight. The 7th, 8th, and 9th question were designed to discover the Johnson's algorithm if students can judge what is happening in the picture. The seventh question is checking the relativity concept. If students can guess that relativity that by adding the just constant to the all edge weights will change the relative paths of the graph. The eighth question is just adding some constants at all the vertices and then adding the difference of two adjacent vertices to the edge weight will make that edge weight positive, and moreover the relativity of the path will not change. The question is asking the students if they can gauge the relationship between the labels and the edge weights of the adjacent vertices. Finally, the ninth question is actually the Johnson's algorithm that use shortest path that are calculated through Bellman-Ford, and then again adding the difference of two adjacent vertices to the edge weight will make all edge weights positive, and still the relativity will not change. For first 6 questions, we provided a help sheet to the students with input graph and the output graph and the name of the algorithm, what is happening in the graph. If students can relate these examples to the questions in the quiz. Now let's analyze the results of the study. There were 20 students in our sample, and the question to the students, we analyzed the results to that if the answer to the question is correct or incorrect, partially correct or totally wrong. The blue color represents the true answer and red color presents the wrong answer. Like first 6 questions are just presenting first question is presenting spanning tree, and second is minimum spanning tree. Third, shortest path spanning tree. Fourth is Dijkstra with positive weights. Fifth, Dijkstra with negative weights. And sixth question is just Bellman-Ford algorithm. And the last 3 questions were related to Johnson's discovery. What we analyzed from the results of the study, that students were not able to gauge the difference between minimum spanning tree and just spanning tree, and most of them were able to recognize the minimum spanning tree and shortest path spanning tree. In question 4 and question 6, but we analyzed the students just applied scripts. They don't have exact understanding of the algorithms because a few of them just mixed up the Dijkstra and Bellman-Ford algorithm. Few of them were not able to identify the problem with Dijkstra while graph is having negative weights. Maybe students didn't meaningfully learn the concept of Dijkstra and Bellman-Ford, so they just mixed up the Dijkstra and Bellman-Ford, or did not find out the difference that Dijkstra is producing the graph with positive weights and graph with negative weights. In question 7 and 9 were quite tough for the students, but question 7 was relatively easy. The students easily judged the relativity problem in the graph. But in question 8 and 9, a very few students were able to identify that what is happening in the graph. They were not able to identify the relationship between the edge weight of the edge weight that we were adding, the difference of the vertices that we were adding to the edge weight to make it positive. The students were not able to identify this relationship, but they were able to identify that something happening in the graph that is making the graph positive, while at the same time the relativity of the path were not changing. The last question, that was calculating the shortest path and then using shortest path to make the edge weight positive. Few students were able to identify that we are calculating shortest path and then using shortest path to make the edge weights positive. But But in question 8, they were not able that how we calculate the labels of the vertices. What is the relationship between label of vertices that we are using, or if very labels of the vertices can be used? They were not able to identify this problem, and maybe this was a new concept for them. So they were, a few students even mentioned that they were lost in the questions. They were not able to identify this thing.
So in formal terms, we can say that shortest path regularities are missing in the minds of the learners. This includes the property which is named as triangular inequality. It states that for any edge uv that belongs to the set of edges of a graph, the shortest path from S to V would always be less than or equals to the shortest path from S to U plus the edge weight of U to V. The value claims of the study turns out to be that there is no meaningful understanding of prior concepts required for Johnson's algorithm is a major hurdle in the way of its discovery. Further, the script-based learning leads to mess up the concepts. We also claim that students who have the meaningful learning identified themselves the relativity issue while reweighting plus the relationship of labels with edge weights. In the perspective of cognitive psychology, the process of education can be considered as an exercise in problem solving involving the acquisition of new information and dealing with a broad range of situations we come across that require integration of information, priority setting, and finding solutions to the problem. Turning towards the conventional education model, it has been regarded as banking model, where the instructor has been a depositor and the learner is a depository, and the teacher has to deposit as much as possible into the depository. The conventional teaching leads neither to understanding the significance of an activity or a procedure, nor does it contribute to the development of a sense of autonomy and independence. In this regard, problem posing rather than procedural question asking can offer students an opportunity to acquire the above stated qualities. Problem posing can take place at various stages of problem solving, that is before, during, and after the activity of trying to solve a problem. Graph theory, branch of mathematics, is nothing but a tool for formulating problems. The formulation of problems that aids in better understanding and analysis and speeds up the process of finding the solutions. Limitations of the study conducted by us is that problem posing took place only before problem solving. We conclude the study by saying that problem posing is an effective technique for discovery-based learning that is the cornerstone of meaningful understanding of the concept. In the study, we have also investigated the strength of this approach in the domain of graph theory. The analysis revealed that 30% of the students were able to discover Johnson's strategy for reweighting while preserving relativity, provided that they have learned the prior concept through banking model. We are of the view that this percentage can be improved if the prior concepts are meaningfully understood. Further, we conclude that banking model is not well suited for understanding graph theory concepts as it limits the level of understanding the new concepts, and even the application or the mapping of existing concepts cannot be done by the learners. That's all. Thank you.